Anton Arhipov. Please greet him with applause.
Thank you. I think it deserves a round of applause for this kind of introduction as well. But okay, my name is Anton, hello. I am developer advocate at JetBrains, and I'm going to be speaking about a fairly boring topic right now. You can tell by the number of people in the room, nobody is rushing in. So my job is to go to conferences like this one or to meetups to meet the developers and discuss problems that they have with continuous integration, the build, the continuous delivery. Learn from them, go back to the team and say, hey, we have to solve the problems for them, and yeah, please implement it in our tool. I've been in tooling space, tooling industry for like 8 years now, and I really like building the tools. And the build pipelines, the topic I'm going to talk about right now came out from my talks, from my conversations with people like you. I was talking to a lot of people during this year, and I realized that different people understand different things behind this term, the pipeline. And hence I want to talk a little bit about this one. So let me ask you a question, a rhetorical question: what is a build pipeline? Anybody? Okay, I don't wait for the answer anyway. So intuitively, it's a sequence of steps, right? You do one step, do the second step. In between of those steps, you may have something like a result, right, that you pass forward to the next step. And at the end, you may have like a final result. Is it like an artifact, a binary, a report, or a deployed software? Something like this, right? Okay, of course, we all realize that this is not that simple, right? It's much more complicated in real life. And if we add environments into the mix, we get this classical continuous integration, continuous delivery picture. And I'm going to talk about that little piece on the left. Mostly, so I'm not talking about the delivery part. I'm going to talk about builds, how you build your software, and why is it interesting to organize the builds into pipelines and what you get out of it. So if you go and check out the tools, you will see that most of the tools are implementing this kind of visualization that visualizes the steps, right, from the left to right. Jenkins, GoCD, TeamCity, and those pictures, mostly, if you talk to people and they say pipeline, they don't really mean environments like development environment, staging environment, and so on. They mean the visualization of the process. They don't even mean exactly the build process, the just general process. From left to right, step by step, please draw the rectangles and connect the arrows. And if we take a step back and think about our builds, what it looks like, you check out the sources, you compile the stuff, run the tests, generate reports, notifications, publish the results, right? So it looks simple, and normal question is, why do I need to break it into a pipeline in a series of steps? Why can't I just run everything at once and get a result? So let me ask you a question: how long it takes to run your tests? Like 10 years ago, unit tests, it runs 3 minutes, you get the result in 5 minutes, good. Today, some of the projects at JetBrains, I would say, it takes 3 hours, 4 hours, 5 hours. At my previous job, if we run all the tests sequentially, it takes 3 months. So you should do better, right? You just can't afford waiting for 3 months to get the result like from your commit. Okay, so what if we do a little optimization right here? So we run just fast tests first and get the result, so that we are sure that, you know, the binary, the result, our commit didn't break anything critical, and we get the final result of the test somewhat later, right? So we get already like 2 steps there, and our beer screams for the pipeline. Yeah, you have my minimal pipeline already. Okay, So you have a build stage and you have a test stage. So from the build you get the result that, yay, you commit did not break the build. And the test stage gets you the quality results afterwards. However, like, it may take some time anyway. So if we start adding the stages, like generating the reports after the tests, notifications and so on, and we start splitting this middle stage to actually make it faster, because like it's a normal engineering reaction to run those things in parallel, right? So we make our builds already distributed. And our build may depend on some results from other build, right? Because our software is a little bit more complicated than just one file and one compilation cycle. And there are dependencies that we use to build our programs. Here the example is, for instance, JetBrains IDE, the IntelliJ IDEA. On the first stage, it builds the platform independent part, like all the Java sources, and then it may build the binaries for different distributions for different platforms, which means it has also to be tested in different environments. So we have to run like different tests in different environments and different operating systems. So you can see where it's going. And we may have like different modules inside our like original repository as well, so that if we start splitting this, we get like a much bigger pipeline. It gets so big so that the web pages cannot render it. Okay, with this I want to get to TeamCity and talk about the issues and challenges and reasons why something is implemented the way it's implemented. So TeamCity started, if someone doesn't know, TeamCity is like Jenkins, but not Jenkins, right? It's TeamCity. So it's a continuous integration server. The internal installation of TeamCity at JetBrains holds about almost 2,000 projects already, and over 2,000 build configurations, meaning one build configuration is a unit of work that performs the build steps like compile, test, run unit tests, generate reports, and so on. And it runs in a cluster with over 5,000 of agents, build agents, so every agent is that worker that will actually perform the build for you, not the server itself. Server is just like a dashboard that orchestrates all this, and agents are the ones that actually are doing the work. And well, it takes nearly 30 minutes to run the build for an average project at JetBrains. So an average project at JetBrains is pretty big. And it all started in 2006, so it's pretty old already, with, you know, for the reason that we actually needed to build quite big projects and needed to build them fast. So here's a screenshot from the internal installation, and I want to point out those numbers. And next I will be talking like about the problems that you get at this scale. So with agents, like you may have like a bunch of agents, but you have to manage them somehow. You have to be able to separate the agents into the pool, dedicate them in like to the team. So it's a lot of administrative work. When you have just 10 agents or 5 agents, you don't have this problem. You don't have like don't have to care about assigning the agents to the teams, because you just have one pool. When you have this many agents, you may have like different properties, different software installed on those agents, and those agents should be assigned to different projects, and different teams should have rights for them. The build queue is getting long at high hours, right? 5 p.m. problem, anyone? Everybody knows this? Like, you want to go home and it's still in the build queue. And you come back in the morning and it's still there because disk out of space or whatever. And there's like almost 2,000 active projects, right? So you need to have something that allows you to manage this number conveniently and build configurations as well. And behind all this is also like 500 people, 500 people who are actually working with this with different rights, different roles, different demands for the continuous integration server as well. So let's get back to the build pipelines. In TeamCity, we have a term which is not, like, historically, it's not a pipeline in TeamCity, it's a chain. So we have build chains in TeamCity. It's not just a sequence of steps, because a build graph is actually a graph. It's not just like one input and one output. It can be many inputs, many outputs. So this is just like a simplest one where I want to explain what is the benefit of using pipelines or chains for the builds. So suppose we have 4 steps that each step is building something. One build is building one module, the other one is building the other module, that depends on the first one, and so on. So each module is in its own repository, version control. One is in Git, the other one is in SVN, the other one is in, I don't know, CVS for some reason. And there is a change coming in. So if a change comes in to that step 2, it's obvious that we only need to rebuild step 2 and step 4 to get the final result. We can reuse something from the past for step 1 and step 3. Why not to do that? So this is how TeamCity works, and you already see that it actually saves us half, like 50% of the time, right, in this small thing. And if we have it at larger scale, it becomes very, very like prominent that you get the benefit of those incremental builds. In TeamCity, we call it a snapshot dependency. Why? Because before the build starts, it will check the revisions, make a snapshot of those revisions, and build exactly all the modules for those revisions. Because why is it a problem? Wait, what is the problem we are solving with this? Is that suppose the first build step takes like an hour to check out a huge repository. Like you do git clone, it takes 1 hour. While it's building, we may have a new revisions in the other repositories, in the second, in the third as well. So we get the revision for the first one, and if we don't make a snapshot before we start the build, we are going to build a second step against the latest revision, but for the first revision of the first step, which may break the build, may make it inconsistent. So that's why we have the snapshot before the build starts. So in TeamCity, we have this configuration where you configure like your build, and you can configure the dependency, and there I have a configuration that depends on two builds, right? And there we have also like a setting that tells it, like, okay, you can reuse whatever was produced by the previous builds. So we already can start saving time and number of builds. So let me amplify the impression here. So suppose we have this kind of build chain, and just, you know, by making a change somewhere in the middle, we have to rebuild just this part of the graph instead of the whole graph, right? So only 8 builds have to be rerun instead of 32, which feels like magic when you really see it working in action. I think it's cool. Have you seen it working in action? Yeah, cool. How many people have seen it working in action? Not too many. That's sad. Okay, we are going to fix it. Another optimization that we are doing in TeamCity to make the build faster for you is that since we have a long queue and the build may be waiting for its turn in the build queue for some time, if it's like a large server, large amount of projects, it might be 2,000 builds in the build queue and wait for an hour or 2 in the build queue. Then we can do some optimizations if we allow that, if the user allows that. So suppose we have projects A, B, C, D with the revisions in the build queue, and there comes another version for project B, and why not to replace it if it's already in the build queue? So it has some implications. Suppose I'm really the user who manually logs into the server, and he really wants to run the build for the revision that is currently in the repository. And this is my intent, right? I want to get the build for exactly that state. And if I'm replacing that build, I'm breaking the intent of the user this way. So this is not what TeamCity is doing. It will not replace the build in the build queue if this build was started by person manually. Instead, we have triggers, and there are a lot of different triggers you can configure for the revision change, dependency change, schedule, whatever, file change, and so on. And there is like a little setting that tells us, yeah, you can replace the build in the build queue if there is a change in version control. So these two optimizations alone allows us to minimize, or basically cut, the build time every day about 7,000 builds, which makes around 40% of whole build time in the cluster, which is pretty good, I think. So I have a little demo. I have plenty of time. And I want to show you how it works. So the thing is configured. Okay, we don't start with the code, but we start with the dashboard. So I have this project right here. I will not start building it by scratch because it takes about 40 minutes or so. But I have separated the projects into 3 sub-projects. I have like a little pipeline of several build configurations chained together in each of those. Like the first one is building something, the other one is building a distribution, a Docker image, and then deploying it to test, and then I have a live environment. So I have organized like this basic, very simplistic hello world pipeline. And I can also visualize it, how it really looks like as a build chain right here. Let's group those by projects so that we see it a little better, maybe. So I have like most of them on the left, and I have 2 small projects on the right. And this all is configured using code. Today is like, it's a normal practice to configure your infrastructure, your builds as code. In TeamCity, we use Kotlin. It looks like a scripting language there, not really YAML, but maybe we get to the point where we provide also the YAML configuration. And there I just describe the whole project, and I can just organize it from the URL, like initialize the project from the URL where is this repository located. So the repository contains .teamcity and this little file right there to configure the whole pipeline. We have VCS routes configured to my local host. I have local Git running, local GitHub. It also supports branches. We say that we want to build the master and we want to build feature branches. And we have, let's say, a sub-project, a development sub-project, where we have a bunch of build configurations. For instance, this library is a Maven project where we define that, hey, which binary it should publish, which are the steps to actually build the project, and to which VCS route it should be connected as well. And if I want to enable all kind of features like merging the branch after the build, and so on. I may also specify agent requirements. For instance, this build should be running on an agent that defines an environment variable that, that my project requires for the build. Okay, so if I make a change, a little commit here, like to the beginning of the pipeline, to the first build, let me do that in a branch, actually, because it's more fun. I will just add a little I don't know, it's a simple class, but I will add public void foo because it's already a commit. And TeamCity will detect that in a second and start building it. And we will see to which stage it progresses. Yes, so it started the build, the agent started, we can see that, just a second. Yeah, the builds are in the build queue. Now the builds are really running on the agents. Oh, it says that it's default branch, but it should be active branches. So it's already finished, actually, and we see that it just built that feature branch for me, where I made the commit, right? So it published the artifacts, it triggered the rest, but it didn't progress to the staging, right? Why is that? Because I have configured it so that the trigger that triggers the build for the change is configured in the very last step of this project. And let me show you that trigger. And that is the only trigger for the build chain. I don't have to configure like a trigger on each configuration. Like, if you finish that build, please start the next one. If you finish that build, please start the next one. Instead, what is the best practice here is to start the chain when something in the dependencies changes. So at the stage in the middle of of your pipeline, you define just one trigger instead of 5, and say that, hey, please trigger this part of the chain if something changes in the dependencies. So it triggered the chain for me, and let's open up the chain. So you can see it's incomplete. It has completed the first stages, the concurrent stages of testing. It produced the report. I can see all the results from the tests from the previous stages in one final place, because it's the composite configuration. So it collects all the results into one place. And we may start now the second part. So the second part is a little bit trickier in the sense of triggering. If I start the build here, then this logic starts to play again, that if this build finishes, then I actually have to start the second one, and for that I have to configure the trigger. There is no other way. And also, if I make a change to that configuration file, whatever is building in that configuration, let me open, okay, I don't have the details here, then we have to also detect that using the other trigger. So in this place, there's like no other workaround than just configure 2 triggers on this very same configuration. One is the trigger that to monitor the previous build if it finishes, and one trigger to monitor the version control. But we may start it from here, and it will trigger the whole subchain. So let's start. So, and it finished quite fast, right? Why is that? Because it actually reused the previous chain results. That's pretty good. So it finished more. Now I have this right to actually deploy the result to production or wherever I want to deploy it, because I have the right. My colleague may not have the right. So if I go and open the other user's dashboard, let me open the chain. No, I don't have to open the chain. I just have to refresh and open that last project. My colleague doesn't have this button. So this is where all kind of administration capabilities comes in. Like, if you have build pipelines, you have those deployment stages, you want to have rights, like assign rights to the users, if able to trigger even this process or not, or it's just the last stage they need to have rights to deploy or not. Usually it should be the manager's responsibility. So suppose I'm a manager and I have this button here. Boom, I can click this one. Okay, so if we look at the history of those builds, let me show you. For instance, in here, we can totally see that this chain was triggered in here. I will not explain why right now, but I want to show this. So those 5 configurations did not run for this particular run because they did not change. We can reuse them. Remember I was explaining about those graphs, right? This is where we win a lot of time and don't waste the resources on a lot of builds so that we can reuse the results. Okay, I actually have just 4 minutes and I made a little demo to you. I hope you have. Now everybody can raise the hand that you have seen it in action, and it's awesome and it's magic. And if you have any questions to me, yeah, please shoot.
The first. So we're users of the Jenkins, and you show us the pipeline where you mix the build and deploy together.
Could you repeat it first?
So we're users of the Jenkins.
Okay,
and in Jenkins we have a pipeline. It's running from beginning to the end, the whole path. So it seems that in your product you are mixing build and deploy together. Is it right?
You can configure, like, one stage can have a type in TeamCity.
Okay.
It can be the normal configuration, it can be the composite configuration that aggregates everything, or it can be a deployment configuration.
Okay.
And the best practice is to separate those, like, build change into the sub-projects so that you can assign the user rights.
Okay. So then in Jenkins we have a build number, and so in this build number I can see the whole pipeline. So it's tagged by number, and so I'm pretty sure that the first step in my pipeline
will generate the build number.
Okay, generate the build number, and the last step will use the artifacts generated in the first step. Yeah, based on your example, so you reuse the builds, the artifacts from the build from 1 to 4 in your 5th step. Could you please show that the 5th step will show us the artifact used in his deployment? Was it been previously built, or the actually build have been finished just before that build? So because when I run the 5th step, here deploy, yes, the 4th, yes, and before that 14. So for example, you can rerun the steps, and what I will use in that step, I will use the artifact generated in the last run or in the previous run.
Oh, okay. I understand the question now. So you want to make sure, like, how you can see that this configuration that uses the previous something artifact, which artifact it actually uses, right?
Right.
Okay. So
based on this UI.
Oh, based on this UI, no, you won't. No, of course, you have to check the configuration. Okay. If you want to see everything, all the details, it will just blow up.
No. So in the configuration, you have a definition of the pipeline, right? So in the definition of the pipeline, you have steps from 1 to 4. The 5th step could run from 1 to 5. So it will end from 1 to 5 in one row. Or, as you described, you can use the previous run of steps from 1 to 4, and you will use it in the 5th without running the whole pipeline from the beginning. So how can I see it in the pipeline on the UI?
Well, in this UI, no, you will not see it. It just visualizes the flow, right? You cannot just display all the settings, but I can show you how to get that if you want.
Okay.
You want to see it now?
Sure.
Okay.
It will be interesting.
So, for instance, if I go to that configuration, that depends on the previous one, right? So I have library and the application.
Yes.
So both of them produce the artifact.
Yes.
Right. If I go to editing configuration and go to the dependencies, I have two types of dependencies, right? The first one is the snapshot dependency that I have explained. The other one is the artifact dependency, where I declare that, hey, I want to get the binary from somewhere.
Okay.
It can be the previous job, it can be some other job from other pipeline as well, right? And in there, I say that, hey, this binary should come from the same build chain.
Okay.
That.
So it's explicitly set, I see.
Yes. In TeamCity, most of the things are explicit. Like there is no. Okay, one thing is not explicit is the feature branches, right? So because I had branches in different repositories, the way it connects them, that hey, I should build branch from the library and a branch in the same branch from the application is by name. So it's kind of a convention. So it's not explicit, right? But other things are explicit.
Okay, and another question. You have a build queue on the UI. Based on the definition of the build queue, on the Jenkins side, we have a build queue, and it will run the whole pipeline. One pipeline is one item in a build queue. When you have a build queue in TeamCity, and as you said, you can run the fraction of the pipeline, not from the 1 to 13, but you also could run it from 4 to 13, so the only portion of this pipeline. Do you also count this item as the build queue, or it's
no, each rectangle
right
on that visualization is a build item.
I see.
So if we have 10 in the build queue, it means we have put 10 rectangles in the build queue, right?
Okay.
So it's not one pipeline that is in the build queue. It's a pipeline that consists of 10 build configurations, and then we display 10 in there.
I see. Okay, and if they, but when you say 10 of them, is it possible to run them in parallel, or they must be run sequentially?
Depends on the definition of those dependencies. So in my pipeline, right here, where was it? Build chain, I have 3 stages that are concurrent.
Yes.
By the way I have connected them and defined those dependencies. So it's a job of TeamCity to figure out what to rerun, can it run concurrently. I may say that, hey, this thing or whatever, they should run on a specific agent, and I only have one of that. So they will be competing, right? So they cannot run concurrently. It just cannot give the resources to run them concurrently, right? We'll actually run the first one, then the second one, depending on all kind of properties that I require from this pipeline.
Okay.
Time is up, actually. We can continue the conversation.
Thank you.
Yeah.
It wasn't a question-answer session now. It was just like a...
Yes, unfortunately, question time is over, but you will be able to ask questions, Anton, before and during the lunch break. And now we would like to say thank you, Anton.
Thank you very much.